In this lecture, we will talk about this example. Use the specified row transformation to change matrix 3, 2 on the first row, 6, 5 on the second row. And here is the row transformation which is specified right here. -2 times row 1 added to row 2. Here the first thing is that we want to understand concept of matrix. And the numbers are organized in this way: 3, 2, 6, 5, and then with the square brackets. This way numbers are organized. Then we call this one is the matrix. It has what? 2 rows, it has 2 columns. So you may write right here is 2 times 2. Alright. Okay. 2 times 2. It's not that easy to see here. So this is a matrix. 2 by 2 matrix we write like 2 times 2. Okay. If I use this pen, it might be clear. So it's 2 times 2. Okay. Right down here. Alright. Now here is the row operation. -2 times row 1. What do we get? Here is the matrix. 2, 3, 2, 6, 5. Yeah, that's the one exactly right here. And then we know the size is 2 by 2. You may write 2 times 2 right here. Yeah, that's clear. Now, -2 times row 1. So what do we get? -2 times 3, you have -6. -2 times 2, you have -4. Okay, so we got -2 times row 1, so we have that. And then is added to row 2. If you added -6 to this row 2, you have a -6, +6. They cancel each other. You have a 0. -4 plus 5, you have a 1. So the second row is changed from 6, 5 to 0, 1. The first row we did not do anything, so you keep it 3, 2. Okay. Again, here is a 2 by 2 matrix. 2 rows, 2 columns. And this kind of operation, like one constant, -2 times 1 row, here is row 1, and added to row 2, this kind of operation is called one out of 3 elementary operations. In general, we have is 1 row multiplied by a constant and is added to another row. So actually, this question won't take us like 5 seconds. Easy to do, but the thing is that you can write you are dumb. You are really dumb here. Okay, that's very easy question. This one. And then, but from here you got what? You got some concepts you need to know. One, what's the meaning for the matrix? And what is the size? 2 by 2, right here, that is the size. You may want to specify that. This is the size. 2 by 2. We have a 2 by 3, 3 by 2, 3 by 3, 4 by 4, 4 by 5. Okay, so this is the size. The first one stands for the number of row. If you want, you may write here is the number of rows. The second one, this number, is the number of columns. Okay, so you've got to understand the matrix, the number of columns, the number of rows. And that's concept 1. Concept, size, 2, 3, 4, and you got one of the elementary operations. So here there are actually many things you got to remember. 5 concepts. What's the meaning for elementary operation of matrix? And here is the one. Okay, one row multiplied by a constant and added to another row. So there are 5 things right here, 5 concepts. Then you may wonder, why do we need to do that? Such an easy operation. Okay, here is something extra. Why do we need to do such an operation? Suppose one is given a system of linear equations as follows. This one, you see down here. Okay, 3x plus 2y equals 2. You see here is 3, 2, 3, 2. And 6, 5, here is 6x plus 5y equals 8. So we know this is a linear system, all right? Now, if you take the coefficients out, 3, 2, 6, 5, so 3, 2, 6, 5, and then this one will be called the coefficient matrix of this linear system. Okay. Similarly, 3x plus 2y equals 2, 0 plus 1y. Actually, I should write 0x plus 1y equals 4. And down here, then the coefficient matrix will be 3, 2, and 0, x plus 1y is 4. So here is 0, here is 1, you put right here. This is the coefficient matrix of this one. All right, we did not include the constant right here. Okay, so the coefficient matrix of this linear system is the one right here. And again, if we are going to find the solutions by elimination method, we would like is to eliminate this variable, 6x. Yeah, this x. How? Row 1 multiplied by what? By -2. What do we get? So you have here will be negative 6x, because -2 times 3, you have a x. -2 times 2y, you have a -4y. And here -2 times 2, you have -4. So basically you do is row 1 times -2 and add to row 2. And then you can see -6x, positive 6x, they cancel each other. So you have a 0x, and which is 0 here. You don't have to write this one. Until now, in order to be clear, I wrote it right here. All right. -4y, positive 5y together is 5 minus 4 is 1y. And here is 8 minus 4, so you have 4 here. And then 0x is 0, and 1 times y is y. So basically you have is y equals 4. So quickly, from here to here, So this elimination method is what? Is really the origin. Why do we need this operation? Okay, yeah. Now, well, 4 equals y equals 4, then you know we put it back here. Then 3x plus 2 times 4 is right here. Okay, minus 8 on both sides because we got here is 8. And then you have a 3x right here equals 2 minus 8 is negative 6 divided by 3. So x comes out, which is negative 2. Is 3 divided by 3 is 1 times x. You have x stands alone on the left, and the negative 6 times divided by 3, you have a negative 2. So x equals negative 2, and y equals positive 4. So basically that's the reason, you know, why we need this operation. Okay. Later on we will talk more about matrix. Okay. Please review this lecture. I'll see you next time.